I'm going to talk about the ASA theorem that can be used to guarantee that two triangles are congruent. So, ASA theorem. What this says is that if you have two triangles and you're wondering if they're congruent, whatever shape they are, all right, and all you know is that they have two corresponding pairs of angles. Okay, so somehow we know that, and let's say it was these top ones, and let's say it was the bottom left angles. Okay, and you also know that the corresponding sides in between those two angles are also congruent. Okay, that's called an ASA situation, and in that case you can rest assured that both triangles are congruent. So in other words, all the corresponding angles and all the corresponding sides are congruent. Okay? Let me show you why that is the case. Okay? So what I'm going to do is I'm going to have you imagine two situations where you have ASA and show you that there's no way that you could make two triangles that are different. Okay? So let's say that we went to Home Depot and we bought two sticks that were exactly the same size. Okay, so I'm gonna lay down these blue sticks right here, and so that's gonna be the S, right? Because we have two sides that are congruent, and now we're gonna make a triangle out of them. All right, but suppose that someone insisted that the other two sticks had to start from the ends, and they had to have the same angle on both sides. The corresponding angles had to be the same. All right. So I didn't say how long the sticks have to be. Let's say this was 5 meters, and let's say the other one was 5 meters, and then I'm insisting that the left angles, let's say, are 70 degrees. Okay, and I'm insisting that that other bottom angle, let's say the angle on the right, let's say I'm insisting that that's 40 degrees. Okay, now, so that's the SAS situation, right? Well, for crying out loud, if those two remaining sticks have to be forced to be at those angles, then there's not going to be much freedom to make a different triangle. Okay, first of all, if we've already set two of the angles, then the third angle also is set, right? Because it has to add up to 180. So we can't change that. All right, so now we have all the angles the same. Plus, these two sticks have to be in this given direction. Now, if we extend those in that direction, then they're gonna meet at the same point. On both triangles, the sticks are going in the same direction, so that's why it's clear they're going to meet at the same point. Okay, and then in this case, we can see that that's going to form a 90-degree angle. Excuse me, is it going to? No, it's going to be 70. Okay, and so lo and behold, we have all three angles the same, okay, and it'll turn out that the sides are the same, okay, the other sides, and so there you have it, two congruent triangles. Okay, so this is a very nice, powerful theorem that you can use to prove triangles are congruent. So let me finish with an example where you could use this, all right? I'm going to draw a picture. And I'm going to make some statements about pieces in the picture. So let's call this top vertex A, and then the other ones B and C, and we'll say this one, that point down there is D. All right, so suppose we wanted to answer this question. if AD is perpendicular to BC, and by the way, that upside down T is the perpendicular symbol. So in other words, it makes a 90-degree angle. And also, so we know that much, and we also know that AD chops angle CAB in half. So it goes right down the middle. You might say it bisects it. Okay? Then, if that's the case, prove or let's say it this way. If that's true, then does triangle, the two triangles that are formed from AD, are those congruent? Is ADC congruent to ADB? All right, so that's the question we need to establish. All right, so let's use what we know to get what we want. So we know that AD is perpendicular to BC, so that means that it forms a right angle on both sides. Okay, so can you see that both triangles have a corresponding angle that's congruent? So that's our A situation. Okay, and now they also share a common side. They share AD. All right, so that's going to be our S. And now we know that the top angle, the two angles formed from AD bisecting CAB, we know those are congruent. Okay, because one of the givens was that AD chopped angle CAB in half. So that's our second pair of angles that are congruent. So therefore we have ASA. So we would say that the answer is yes, and maybe add a statement like this can be shown from ASA. ASA is why we can take it to the bank and be guaranteed and not have to lose sleep. Okay, ASA theorem.